seat now. Well, what do you want to know?
Yeah, as we walk in, we're just really curious about like how you like build the car, the whole process, and like what was the basic steps you walk through the process.
Magic. We are the Illuminati. Actually, we had this just sitting in one of our cabinets along with the 100-mile-per-gallon carburetor. We decided to pull it out. May as well. Time's right. Next year I think we're going to do that, really cool foil that we showed you guys at Area 51. When you crunch it up, it pops back out. It's nothing to do with spaceships and stuff. It's just a way of making aluminum foil. Anyway, well, how we started with this is X-Prize said, we want somebody out there to build us a 100-mile-per-gallon car. And we said, well, we're somebody. We're out there. We think we can do it. What do we need to do? Well, we have to have an efficient drivetrain. We have to have an aerodynamic shape. And we have to try to keep the weight down. Ooh, weight's really expensive. Okay, that's tertiary. We'll do that last. And everyone else with money will worry about weight first. So the first thing we did is we tried to figure out what we needed to do for the drivetrain efficiency, and then the size of the vehicle, and then how to do the aerodynamics around it. Requirements of the competition where you had to be able to seat 4 full-size adults, have 10 cubic feet of trunk space, certain acceleration times, deceleration times, range, what else? A whole bunch of stuff. You can go online and read all that boring stuff. Stuff is also a very technical term. You might need to remind people of that occasionally as you're using this as the word stuff. Just reference your other word for the full definition of that technical term. So we sat 4 guys on the floor and we said, okay, we need the 4 biggest guys we got, shoulder to shoulder. Are you comfortable? No. Okay, scoot apart a little bit. No. I'm sitting on the floor. I'm not comfortable. Okay, let's get some chairs. Sit them on the floor. And we started marking out on the floor with some chalk line that you use for putting a building together and just snapping out the lines. Is that enough room? Yeah. Okay, now everyone rotate. Everyone still have enough room. Shuffle around. Because it's like cards in a deck. Each card is different. Each person's different. You have enough room. Are you tall enough? And, okay, that should imaginarily do it. Okay, everyone out of the car. Now we have to have room for the drivetrain and a trunk. Well, what's 10 cubic foot? Well, 10 cubic foot, if we make it this big and this tall, would be, and snap some more lines. And then for under the hood, we made it like a 1.5 feet long, and then the width of the car. And then we made it longer for the aerodynamics later on. So we kind of built it as we went. But we had the basic design. And we went to the junkyard, and we got parts from cars, suspension and stuff, and laid it out on the floor, and then modified it so it fit our drawings. And then took tube steel and welded it all together and went, yay, it's done. No, wait, no, it's not. And then we cut it apart and redid it, So we had finally had a rolling chassis that fit inside those chalk lines. But we literally snapped the chalk lines on the floor, set the tube steel on the chalk line, lined it up with the suspension, had the guys hold it together so it was nice and square. We measured our angles, made sure tack welded it together. Finished welding it all together, built a car. Yay, we did it. Now we have to make it work.
Yeah, that's a very interesting process. In school they also teach us to build a computer simulation, computer prototype, all those stuff. Why did you choose to use that process?
None of us knew how to do it that way. And we don't have the youth or ambition to try to refigure out how to do it that way. So we knew that classically the way they built cars was simply you set the driver on the floor, you're going to use this person as the driver, here's their seat, you have certain knowns, and you work around those knowns. So that's what we did. We took the known quantities that we had and we built a car around it. And then we did some CAD after. Not great CAD, but it was stick drawing CAD of all the frame members. So as far as that goes, it's awesome. But as far as what you're required to do for the solar car with the 3D imaging and being able to rotate it and go, okay, this is this, here's the angles, and everything's calculated. You put a point on the side of your picture and it tells you the exact angle, the curve, and the point you are in the car. We'd go, wow, it'd be nice to have that. But we didn't have time to do that. And then we also don't have the equipment to build from those drawings.
Right.
We knew what we had and we made a plan around that. Kind of like you're working on a solar car, right?
Right.
So your plan is you have all the designs and drawings, and now you go, okay, now we got to try to make this stuff, refine it. We're talking about a little bit of that and how you're going to do it. So you've got a completely different set of challenges to meet the same design goals. I want a car of about this size and shape that does the following. But the way you're doing it, you should be able to eliminate a bunch of the problems we ran into. We had wiring issues, we had battery issues, we had. Yeah, the motor and transmission almost didn't fit in the car. We had to shave out the foam and fiberglass to 1 layer thick fiberglass between it and the tires because we were that close. We thought we had an inch of space. And after the time you got the coupler in and everything bolted in and set down and mounts put in and the car put together and you set it in, you go, it touches everything. So you run into these little issues and you might with your drawings. But if you knew the exact motor that you're using ahead of time, you could use the drawings and go, okay, this is the exact size I need. You can take it and you can move it around in the picture. We had to do it physically, which, depending on your resources, will depend on how long it takes. Right? We didn't have enough resources to do it the way you were doing it. The way you're doing it is the way you're going to do it when you go out into the market, the real world. Right. We had to do it based on an older school type of approach in order to get it done with the equipment and the skills that we had.
It's a very interesting perspective. So I'll assume that during the whole process, new constraints will come out, you have to change, modify, all that stuff. So
yeah.
How do you feel after everything is gone like this and so beautiful?
We're happy with how it came out, but we're still continuing to work. As you saw, there's the motor sitting over there, right. The transmission's over there, the seats are out. We're working on improving the drivetrain efficiency right now. We're going to be working on the body some more this winter. We only had so much time to work on it before the competition, so we didn't have mold. We built all this by hand. We sanded and shaped it all by hand. So it's got some rough spots. It's got some wrinkles in it. We want to go back and fill that all in and make a mold off the car so that we can go back and we can make the perfect body shapes for it. So you can make a fender, but more importantly, because I drive it out on the road and I like driving fast, so that when I get in an accident, I can fix that car because I got mold, as opposed to going, that was custom one-off, and it's going to have to be that way again. The way you're doing it, you can make another one, which is very important in production. Now, if you make your first one and go, this worked great, let's do the same thing and make these couple changes. We got the mold for the car here, let's pop out another body, and let's make the wheels different, or let's change the suspension configuration, or let's change, we don't have that to work with. This is it. So there are limitations in the way we built it. The way you built it, you're going to have more to work with when you're done. We're kind of backpedaling right now. We want to make a mold off this car. You're going to make a mold and make the car from it. So the way you're doing it is a much more pre-production oriented version. Ours is a one-off, get it done as quick as you can. You will learn a lot more about modern manufacturing, techniques for building, and just modern design and computer work that we learned on this. But you're also a college student, 20 years younger than I am anyway, and I'm one of the younger guys on the team. So you should have a huge advantage in ambition and youth and being able to stay up for 3 days straight at a time. When you're almost 40, that gets hard to do.
Yeah, sure.
Not to mention when you're at retirement age, right, George? Okay, we probably made this video long enough. Are there any other wrap-up questions you guys had?
Yeah, so we're really impressed by the time you put in, the work you put in, by how it turns out in the future for Illuminati.
Yeah, actually, we would like to go into pre-production. That's what we're planning on right now, which would be a small scale. The cars would still be made one-off. We're trying to get to where you're going with the solar car. We have a mold and we have a chassis design, so that if someone came to us and said, here's some money, make me one of those, we'd go, no problem, put it together. So that's what we're aiming for right now. Once we get enough of them out there, we can show people that it can be done. Because most of the competition, well, we would have liked to have won $10 million. It's kind of nice to have and all. It's convenient. But most of the competition was about education, showing what is possible. We did it from a garage or a barn out in a cornfield, and we're getting over 200 miles per gallon with a 3,100 pound car. So, and it seats 4, it goes from 0 to 60 in like 8 seconds, and it's a 200-mile range, and all that kind of good stuff. But we did it with Visa, MasterCard, and my friends and family, and I still have all those friends and family.
That's good.
And Visa and MasterCard haven't come to take me away. So, we did okay. We minus the $10 million, and we made a bunch of friends and learned a whole bunch of stuff, and we're continuing on with it. And I would really like to see you guys again once you finished your solar car. Maybe we could do a head-to-head race.
What's that?
Awesome.
Good talking to you.
Good talking to you, Janice. Thank you.
For your audio,
Thank you.